What technology do you have to know to be a software developer? I think that's a trickier question than it first sounds because, yeah, you've got to know a programming language, right? But there isn't a specific one you have to know. No matter how big a fan you are of Java, you've got to admit that someone could have a very good career without ever learning it. Same for any other language. No matter how much you love it, there isn't a single must-know language. Same's true for databases too. You probably need to know how to use at least one database, but there isn't a particular one. I thought maybe I could say the command line. It's very useful. I wouldn't want to live without it, but I don't think you have to know the command line. And anyway, I'm not convinced it's a single tool. There's only one specific tool I could think of that comes close to the definition of must know, and that's Git. I mean, is there anything more ubiquitous? Is there any tool that you will find in just about every type of project across the world, in every language, for every stack? Git is everywhere. It's devoured the version control world. It's devoured the keeping my software safe world. But as great as it is, and as much as I love it, there are definitely opportunities to improve its usability. So, is my guest this week trying to take the crown from the world's most established programming tool, or is he just pulling on a few design threads and trying to see if he can make something better? With me this week is Martin von Zweigbergk. He's the creator of Jujutsu, or JJ. It's a version control system. It's Git-compatible, but it tackles commits and versioning in quite a different way. A couple of my friends recommended it to me, and I've been trying it out recently, and it's been a bit tricky because to use it, you have to unlearn a few Git habits. But the upside is undeniably it has better undo, better redo, easier merging, better conflict handling, much easier rebasing. I'm going to recommend you check it out if you've ever been frustrated by a merge. And I think that's just about all of us. But before you try it out, let's dig into what it is, how it works, and why Martin created it. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Martin von Zweigbergk. Joining me today, live from Google's offices, of all places, Martin, how are you doing?
Hi, good, thanks, yeah.
Glad to see you here. And hear you here. I've got to remember it's a podcast as well as a video episode.
Yeah.
So you came onto my radar with a very interesting project, which you're going to have to explain to me first why this project needs to exist, because I know a lot of people are going to wonder what's left to solve. You've created a new version control system, which isn't Git. And Git rules the world. So why are you taking on the king?
Yeah, that's a good question. So at work, I work on source control here at Google, and have been working on that for about 10 years, I think.
Okay.
And we do some. We have an integration of Mercurial that we integrate with our in-house monorepo. That's like Perforce-like here at Google. And yeah, so I've been working on that project for many years before I started this one. And we had been talking about in the team, like what we would like to improve with our solution here, our internal solution. And one of the ideas that came up was like automatically snapshotting the working copy. There were like various other ideas, but like this one, I found very interesting what the consequences would be for the UX of the VCS especially.
So this is the thing where instead of staging everything to make it kind of semi-permanent and then committing it to make it actually permanent.
Yes. Yeah. So,
Okay.
so yeah, exactly. So like if you snapshot the working copy, so it becomes a commit. So like there's no, then it means basically that you have no changes on top of your working copy. And so your working copy, or like in the Git sense, the working copy, there's no dirty working copy in a sense. So you're always free to move around between commits. But yeah, so this idea of snapshotting is how the project started. I found it very promising to. I wanted to experiment with the UX of that and see where it led. So that's how it started. I mean, I didn't know where it would lead then, but that was hopefully would work out.
I love projects like that where you just get something a bit between your teeth and like, let me just see where this goes.
Yeah, it seems like it went well so far.
Okay, so where did it go?
Yeah, so I started with that. And just I think from day one, it was also I had like pluggable backends because I wanted to be able to, like, if it turned out to be useful, I wanted to be able to use it with Git repositories for everyone outside of Google, and also within Google with a different storage backend. So I had support for Git backends from day one, I think. And yeah, so that's of course very useful for being able to like experiment and do anything if you can use it on existing repos.
Of course, yeah. So you've got a massive like test bed of all the different Git repos in the world. Should you want?
Yeah, and of course it's very hard to compete with Git if you're not compatible with Git, at least at the repo level. Like, so if you can't clone someone's Git repo, it's very hard to get users because the whole team has to switch.
Yeah, I've already experienced this. I was trying Jujutsu. We actually haven't said the name of it yet. Jujutsu, JJ.
Yes.
I was trying it out, and of course, the first thing I did was try cloning someone else's repo, and then checking I'd be able to push it back without them knowing I was using JJ.
Yeah. Yes.
So tick that box.
Yes. Yeah. Exactly. That was an important requirement. So I experimented with the working copy as a commit concept and to see how that went, and it seemed promising. So I just continued working on that, and then kind of as a consequence, mostly of that, I had to figure out what to do with merge conflicts. So because when in Git, when you merge two branches, for example, and you run into merge conflicts, you're in a state where the Git has to keep track of those merge conflicts, and it does that in the index. It keeps like the different sides of the inputs in the index in the staging area.
Yeah.
So since I wanted to be able to like store everything as a commit and be able to switch freely back and forth between commits, I had to figure out something for some way of storing these conflicts. Or
right, because it's when you've got a conflict in Git, it kind of jams the whole thing wide open with conflicts, and you're just stuck there till you do something. But you're wanting to take that itself as a commit by your very initiating idea.
Yes. Yes.
Yeah. Okay.
Yes, exactly. Yeah. I mean, it would be an option to be in that state where you're stuck, but like I really didn't want to ideally be in that state. Like if you're free to move around, I mean, you lose basically many of the benefits of being able to freely move around between commits if you're stuck when you have a conflict.
Yeah. A number of times I've just abandoned my attempt to merge something just so I can get something else done while
Yes, exactly. Yeah. So that was the next thing that that I had to solve, kind of. And initially, well, so we store how we store these conflicts is whenever you run into a conflict, we store the inputs of the conflict. So if you're rebasing. Well, if you're, let's say you're merging commits B and C with A as the merge base.
Do you know what? We'll get to that thought. I'm going to interrupt you and wind back a bit, because I found the experience of using JJ to be like, you learn so much to learn how Git works. You're like, no, you can't commit something. You've got to understand what a staging area is first. And by the time you've got through that learning hurdle, it's hard to imagine doing it another way. And in some way, JJ seems weird because it's simpler. Like, there is no staging. Can you just try and give me a mental model for how I approach this thing as a user?
Well, I mean, to me, I came from I used Git, and I even contributed to Git like 15 years ago or something. But then when I joined this team here at Google, we integrated Mercurial with our in-house monorepo, as I said. And Mercurial also doesn't have a staging area, so at least I was used to that model, or I had gotten used to that.
So your mind hasn't been bent into that shape the way mine has.
Yeah, I guess it got straightened out. On the way. But Mercurial has like a similar model in that sense, that there's no staging area, and instead it has nice commands for like what Git users usually do. I think add -p or something like that to build up something that's ready to commit in the staging area and then commit it. In Mercurial, there's there's an interactive commit command that's basically the same, but then like if you want to adjust that before you commit, like in Git, you can add more and more to the staging area and build it up until you're ready to actually commit. In Mercurial, you simply commit it and then you adjust. You can amend. There's an interactive amend, which is like serves the same purpose basically as the add -p after you already have something staged. So anyway, there are, without the staging area, you can do the same things. The staging area isn't really needed as long as you just accept that you create the commit before it's actually ready.
Yeah, this is the weird thing to me. It's like everything's already always committed, but then you might but when you actually like, okay, that's final, then you push on to the next commit, and it's all backwards. You create the commit first, and then you add stuff to it.
Yes. It takes a while to get used to. I think the commit is just a way of storing the state. It doesn't mean that you're ready to send it for review or anything. So if you kind of accept that it's just a way of storing your changes, then it's maybe not so strange.
Yeah. I think I've been playing around with it a lot. I'm beginning to get used to it, and I'm beginning to actually really quite like it. In that it feels a lot less formal than Git, but I think I'm right in saying it's equally powerful.
Yeah, I would say so, at least. I think we have a lot of functionality for moving commits around and moving parts of commits around that are much easier to use and more powerful than Git's.
Tell me a bit about before we get into merging, which I know is juicy. Tell me a bit about the equivalent of rebasing and shuffling commits around.
So there is a rebase command, JJ rebase, which is similar to Git, and it works kind of the same way. But it also has, like, we don't have an interactive rebase command, so there's no, if you're familiar with what that does, it lets you rewrite history, rewrite the commits as you go. So you can stop in the middle and edit the commits, for example. JJ's rebase command does not do like both of those things. It just moves commits around. It doesn't let you edit them while you're moving them, as Git's interactive rebase does. But other than that, they're pretty similar. JJ's rebase command is more powerful in that it lets you rebase like a whole tree of commits, not just one chain of commits. And it always updates bookmarks to match. And then of course, there's the merge, the conflict handling that we have that we'll talk about later.
And I guess you don't need the edit in the rebase because you can just jump to any commit at any time and edit it.
Yes, exactly. Yeah. Yes, exactly. So instead of this interactive rebase having like the edit and squash and so on, as part of the interactive rebase, we have separate commands for those things. So we have an edit command that makes the working copy point to the commit you tell it to point to. So, and that can be an ancestor commit. It doesn't have to be like the leaf commit. So so your working copy can actually be an ancestor of some other commits. And I haven't said when we do the automatic snapshotting, but like whenever you run any command, any JJ command, the first thing that we do is automatically snapshot the working copy.
So every time I type JJ, you are creating a sort of mini commit.
Yes. Yeah. I mean, it's a regular commit. It has all the changes that you see in the diff. But well, if nothing changed compared to last time, then we don't create that commit. But yeah. So if you're editing a past commit, then whenever you run a command, we snapshot that and we see that something changed. We create a new commit, and we rebase all the descendants on top. So if you had a chain of commits there, you will still have like a linear chain of commits on top.
Yeah, so this is something I've tried to do in Git, and it's painful and seems to be easy in JJ. You can go back and edit a commit in the history, jump straight into that, change it, and everything ripples through, usually without merge conflicts.
Well,
a lot of the
that's
time.
The same as Git. Yeah.
You would it just seems like there's so much less machinery in the way you're doing it.
Yes. Yeah, I think so. Yes, I think it's a lot more. It's a lot simpler to do, but we would run into conflicts in pretty much the same cases.
I guess I have to ask you before we move on from that, if you're snapshotting, if you're creating commits every single time, and I know you must have tested this on some very large repos if you've used it at work, is it like is it a serious performance hit to create a commit every time?
No, not.
Why not?
I mean, creating commit is pretty cheap. It doesn't take long. Rebasing is also not terribly slow. I mean, it's not. If you tried it, I did some performance tests like years ago, and in the Git repo, and we were able to rebase about 1,000 commits per second. So it's like if you use Git before or Mercurial or something, that seems very fast. But like the reason Git and Mercurial are slow, or at least the reason Git is slow, is mostly because they do the rebase in the working copy. As you rebase each commit, you update the working copy to that state and run any pre-commit hooks and whatever. There's a git replay command that does this basically the same thing as we do like rewrite the commits in memory, and that's a lot faster. So okay, creating commits is not that slow really.
But I would have thought there's a performance hit to rescanning the file tree and rehashing all the files to check they haven't changed.
Yes, that definitely that can be slow. But Git has that problem with Git status too. It's you have to scan the working copy to see what has changed.
I suppose it must do.
Yeah, we have integration with Watchman, which is a file system watcher that makes that faster if you are in a very large repo, or like a repo with a large working copy.
Okay, I'm jumping around here, but you have to be okay with that because your very tool lets me jump around the branches very easily. So, okay, so if it's not performance hit, you are scanning every time, you're storing everything as a commit. I think we need to talk about how you're storing things, because is it literally the same as Git? Because you're kind of giving me the impression that JJ is kind of a user-facing tool over a Git storage engine.
Yes and no. So yeah, I mean, as I said, we have pluggable backends, so we can work inside of the Google repo, for example. So at Google, we have a different storage backend where we write commits to a database. So that's very different and obviously not Git backed.
Yeah.
But also, like, even if you're using the Git backend, we used to store some of the data outside of the Git commits, and because we haven't talked about it yet, but like in one of the first things you see when you run JJ-log is what we call the change ID, which is like a stable identifier that follows a commit as it gets rewritten. So if you change the description of commits, it keeps its change ID, even though it gets a new commit ID.
Right. Yes, because if you're creating a new commit every time something changes, I'm going to end up with a vast number of random chars. I need something to refer to my logical thing I'm working on today.
Yes. Yeah. I mean, we could use the commit ID just like Git does, but it's just the change ID, the stable one, is just much more convenient. It means like if you run JJ-log, you see some change ID, you can, for example, run JJ describe to update the description of that commit, and then you can rebase it again without having to look up its new commit ID. You can refer to the same change ID as it had before, because it keeps it.
Right, yeah. That in itself is useful.
So yeah.
Okay.
Yes, the change IDs are very useful for just using on the CLI. But yeah, back to where we store stuff. So the change ID, for example, is something that we have that Git doesn't store in its commits. So we used to store some stuff outside of the Git repo. So we create just regular Git commits with a few pieces of metadata in our own custom storage on top of Git. But yeah, no, like gradually we have moved all of these into the Git commit object. So these days we store this change ID in as a Git header in the Git commit object. So if you push that to remote and someone else pulls using JJ, they will see that same change ID.
Okay, so to make sure I understand this, I know that when Git stores like a file, it stores something like the string file and then a size and then some header separator and then the actual contents of the file.
Yes, but that's a different thing. That's how it stores blobs, so files, as you said. But commit objects are stored with some headers, and like one header is the committer, and one is the author,
and the
one
parent.
is the parents, yes, and the tree it points to. But you can add custom headers there. And that's what we do. We add this change ID as a custom header.
Okay. So a Git header for a commit is basically key value pairs in the header, and you can just add stuff in.
Yeah.
Okay. And then this file objects and trees are the same?
No. So in the Git model, there are files or blobs, which is just file content, and then trees, which is like a directory, and those are recursive. So like you would have one for each single directory, and then they point to the child directories. And then at the top, you have one single tree for the root directory, and the Git commit object points to that tree. And JJ uses basically the same model. That's how we're able to be so compatible with Git, because the models match very well.
That also sounds more than simple enough to store in an arbitrary database too.
Yeah.
Modulo garbage collection, because if you're snapshotting all the time, you must generate more unused commits.
Yes, definitely. It's usually not really a problem, but yeah, you can. We do have garbage collection these days. Like there's a command to like abandon. We haven't talked about the operation log. We'll get to that, I guess.
Definitely.
But like you can tell it to abandon old stuff, and then we just subprocess to Git's GC to garbage collect the actual Git objects.
Okay. So yeah, okay, I can see how it's quite similar. So the next thing I definitely want to talk about, we're working our way towards merge, but I'm assuming they're the scariest part of this, so we'll save it. The op log. This is interesting. This is the first really compelling reason to snapshot everything. Tell me about the op log.
So the op log is it actually started as a solution for concurrency problems.
Okay.
So we have at Google, where we use this Mercurial thing on top of you store Mercurial repos on top of a distributed file system, and this often runs into once in a while at least, it runs into concurrent writes from different machines, and which corrupts your repo.
Right. Fun.
So the op log started as an attempt, a successful attempt, I think, to solve that problem. And what it is just if you think of all the branches in your Git repository, for example, or all the refs, including head, we just basically snapshot that. So the op log contains like it's similar to commit graph. It's a DAG, just like a commit graph, and it keeps track of where all the branches currently point at every point in time. So after every command, we update this, create a new operation, and with a snapshot of where all your branches, or like bookmarks as we call them, point.
And this is the thing that enables me to kind of micro undo.
Yes, yeah. So yes, so I said it started to solve the concurrency problems, but yes, it's very useful for being able to go back in time. You can restore your repo to a past point of, like, if you rebase something and you decide you didn't actually want that, you can go back, and you can go back multiple steps, not just one step, and we can load the repo at any point in time, and you can run JJ log at the specific operation to see what your log output or any command output should look like at any point in time.
Oh, okay. So I can go back and get the log as it was before I rebased, trivially. Yeah. Okay.
Yeah.
One thing I found, I've been playing around with this a lot. You're luring me in slowly. But one thing I found really useful is I often, when I'm developing with Git, I will put things I definitely like into the staging area, so that I can easily throw away the other changes if I need to, but keep the important ones. But I don't yet want to commit them, and maybe I should. Maybe it's a bad habit, but that's something I do. And I have definitely run into the case with Jujutsu where I sort of wished I'd done that on a more fine-grained level, and I can just undo individual snapshots I took without even thinking about taking snapshots. I can step back to where I was a few minor changes ago. So like the way I'm staging things, but even more fine-grained.
I think what you're asking is for, like, we don't have a very good way of doing that today. I think we should make it simpler, but there is a JJ evolution log or evo log to look at the past snapshots of a single change. So, as I said, the change is this thing that stays constant as you modify it, and every time we snapshot, we amend and into the same change. And the evolution log shows a log of how your working copy or any other commit has been rewritten.
So there will be a future where I get an animation of all the all the deltas that came in to make that change.
Yeah. I mean, there's a JJ evolog-p to show the deltas. Yeah.
Okay. Someone's going to be training an LLM with that before long. All the extra data about how working commits are gradually evolved. Yeah, can totally see that. Okay. I think we've got to go for it. We've got to dive into conflicts. So here I am with a system that's a lot like Git. How are you handling conflicts? How do you do it better, do you think, than the way Git handles conflicts?
Yeah, as I said, we record conflicts in commits because we want everything to be a commit, and it's not the conflict markers that we store. People often think that when they hear that we store conflicts, they assume we just store the conflict markers.
Yeah, I assumed you were just storing broken up files that won't compile anymore.
No. So what we store is the inputs for the merge. Like if you have some base commit A and you have commit B and C as children of that, and you now want to merge those two, what we store in the child commit then is those three inputs. We store the tree that's from A as the base, and this tree from B and C as the two sides that we have to merge.
Yep.
And then, like, if we can resolve that automatically, then we do that, and we just store the resulting tree in this child, the merge commit.
Right.
But like, if we can't, then we keep those three input trees in the commit, also as this kind of Git commit header, as I mentioned before. We use that for conflicts too. So if there's a conflict, we store multiple trees instead of just Git's single tree.
Right. References to those different trees.
Yeah.
So you're not taking up much space. And presumably this works because it's always cheap to recalculate what the conflicts are.
Yes, it seems like it might be a bit expensive, but it's not too bad. Like exactly. So we do that on the fly whenever. So if you look at the file, if you check out this commit, for example, we redo that conflict resolution, and of course, since this was presumably a conflict, we had some conflicts. That's why we had multiple trees. Then we materialize those conflicts as conflict markers in the working copy. So when you check it out,
the inputs are immutable. It's a pure function to calculate the conflicts from those immutable inputs. Yeah. Okay.
Yeah,
I can see that.
Yeah. So whenever you check out the commit, or you diff, or like restore the state from that commit or whatever, then we would calculate those conflicts on the fly.
So if I go back in time 5 commits, and we're all going to want a diagram for this, but I'm going to try and describe it accurately. If I go back in time 5 commits and try and merge in something new that's conflicted, that's going to be updated to store the inputs that would conflict.
Mm-hmm.
What happens to the first descendant of that, which is now supposed to be based on a conflicted merge?
Yes, good question. So here we do something that I haven't seen anywhere else before. We do some simple algebra on conflicts states. So in the conflict I mentioned before, where we had base A and trees B and C that were merging, the conflict state there it will be like B plus C minus A, or like equivalently C plus B minus A. So if you think of the changes that were introduced in commit C, that was based on A, so that diff is C minus A. So if you apply that on top of B, then you get this this expression.
Yeah. Okay. Slow down a second. You can treat diffs as algebra of one commit minus another commit. Yes. Yes, you can.
Yeah. Yeah.
Thank God you're doing it, but
yeah. Yes.
Okay, carry on.
Yes. It's not obvious, but it's pretty simple once you figure out that you can do this. And then the expressions also, like these expressions, I mean, there's very simple expressions, just plus and minus. So what happens with the descendants that you, I'm not going to try to describe those expressions in detail because it's hard without the picture.
Yeah.
But yeah, we propagate the changes. So like if the commit on top was commit D, for example, and its parent was C, let's say, then we apply that. Then we add that to the expression we had from this new commit that you mentioned.
Right.
And like in some cases, that simplifies and becomes not a conflict, or becomes a simpler conflict, for example.
So I'm picturing some kind of simple addition subtraction expression where, just like regular addition and subtraction, sometimes things cancel out and simplify, and you end up with hopefully one term at the end, and that's great. And if it's not, there's a conflict, and we still need to address it.
Yes. Exactly.
And presumably sometimes that means when I resolve an earlier conflict, the subsequent equation just magically flattens out, and I don't have more work to do.
Yes, exactly.
That sounds really quite elegant.
Yeah. It turned out to work pretty well. So one simple example, one way to test this is like if you rebase a commit somewhere and it results in conflicts. If you rebase the same commit back to where it was before, the conflicts will go away. And I mean, you can do the math on a whiteboard after or something, but it's pretty simple, and it works in practice.
Yeah. Are you doing that on a per commit basis or a per file basis?
Good question. Both. So this merge conflicts algebra, we do it in lots of places. We do it initially at the tree level, and if there are conflicts there, we try to descend into subtrees and so on, and then we descend into the files, and then we do use the same algebra for the individual hunks in a file, different. So hunks are the different diffs, parts of a diff. And we also do it at higher levels, like refs, when you update, when the remote changes a ref, like a bookmark, moves a bookmark or a branch forward, and you move it forward, then we do the same. We use the same conflict algebra for those, and like in some cases they simplify and become not a conflict, and like otherwise you can have conflicted bookmarks in JJ. So if you change the bookmark and the remote change the bookmark, then you will have, in some cases, you have a conflict, and you have to resolve that.
Yeah, I'm still thinking in Git terms, but this is when your two branches have diverged in a way that can't be automatically resolved.
Yes.
Yeah.
Yes. Okay. In those cases, we will mark the branch or bookmark itself as conflicted. Yeah.
Okay. That on the surface, getting conflicts in bookmarks as well, that worries me. But it does lead to a system where you can jump around, get work done, and come back to resolving conflicts when it suits you rather than when it suits the version control system.
Yeah,
which is nice.
Yeah, it's not that different from Git. You can still have divergence. It just doesn't get displayed in the same way, kind of. Like if the remote branch was moved forward and your local branch moved forward, then you will still have to resolve that somehow in Git, like the origin /master and just the local master or something.
Yeah. Okay. I think I have to go and ask this now. What is a good language for writing a mixture of file system scanning and difference algebra? What's this written in? And is
Rust.
it a good choice?
Rust.
Okay.
Yes. Yeah. It was just not much thought was put into it. I had heard good things, and I wanted to learn Rust when I started the project. So
fair enough.
I picked Rust.
I was wondering if you were going to say Go because of your origins.
No, I've never been attracted to Go for some reason.
Okay.
And I should say that some thought was put into it. Like in particular, our experience from Mercurial led me not to want to use an interpreted language. At least, like Mercurial is written in Python, and we have so many performance problems with mostly because of that, I think.
Oh, yeah. It seems like something you want to write in C or one of its descendants.
Yeah.
Yeah.
I didn't want to write it in Java or Kotlin or something either.
Yeah. Okay, that's fair. That's both Rust, Go, and C ought to be on the shortlist for a project like this. Yeah.
Well, for me, not C. It's just too hard too easy to make bugs and too hard to write to be productive for me, at least.
Okay. In that case, let's go back into feature space for this, because there are, like, as soon as you say I've got something that works with Git, people are going to say, does it do X, Y, Z that I'm used to from Git? And I'm afraid I'm going to ask you those questions. So we've talked about merges and conflict resolution. How about bisect? Can I do the equivalent of Git bisect?
That's something I really want to add, but haven't found time yet. The good thing is if you're in a Git repo, you can use Git bisect.
Does it still work?
Yeah.
So can I do both tools coexist on the same repo happily?
Yes. We have we call it collocated mode when there's the .jj directory and .git directory are both in the same workspace. And then you can run JJ commands and Git commands. And so how that works is whenever you run a JJ command, we check what the latest state in Git is, and we import any recent changes. And then, like at the end, after we have finished running the JJ command, and we update the Git bookmarks and head and so on. So to make it match.
So I could use JJ a bit and then go running back to Git when I need something familiar for a particular operation.
Yes.
Okay. In that case, I'm raising my hand for the feature request of bisect.
Yes. No, we definitely want that.
Okay. Is that going to introduce a new performance issue because you will then you can't do everything in memory anymore? You need to check it out physically to the file system in order to run a bisect execution command.
Yes, that will have to run in the working copy.
I guess that's a price worth paying.
Sorry?
I guess that's a price worth paying if you actually want to bisect something.
It will have to run in some working copy at least. We could possibly make it run in a different working copy, but you will need to do a build. Typically, at least you would need to do a build and run some tests and something. So,
okay,
it needs a working copy.
I can think of one thing that you might might do in a bisect-ish way that would still work in memory. So let me ask you if you've got the equivalent of git grep. I want to grep through everything that's been checked in.
No, we don't.
Okay.
Yeah. I guess we will get that someday, but yeah, no.
Okay, that's fair. That's fair. I could probably just check it out myself and grep.
Yes, yeah.
Okay.
Yeah, we do have the pickaxe git log -g or -s. I forget which one is which.
That's the one that searches through all the old commits looking for the string you want.
Yes.
Okay. That's very useful. Sometimes that's the hard one, isn't it? Because git grep is just searching your working copy and ignoring the git ignore files.
Yes.
The searching history is the one you actually need a tool for.
Mm-hmm.
Okay.
Yeah.
And this is a feature, because we live in the age of LLMs and agent-based coding, this is a feature I find myself using more and more and more. Git work trees, where you can have multiple versions of the same repo checked out on your file system. And when you commit to one, you've committed to all of them.
Mm-hmm.
Do you have that?
Yeah. That's been supported for a few years. Yeah. It works in a very similar way.
What made you add that one sooner than, say, bisect? Is there a reason?
I'm not sure. Yeah, I'm not sure. We want that at Google, but I'm not sure how important it actually was. But yeah, I don't know. It wasn't that hard to add, and it fits nicely in the model, and so yeah. But yeah, bisect is not really that much work either. It's just that no one has prioritized it, I guess, because they fall back to git bisect or instead. I mean, I mostly want it at Google, so it would be really nice whenever someone finds time to implement it.
Okay, that makes me wonder how many people are working on Jujutsu.
You mean upstream, like the open source project?
Yeah.
It's. I mean, people are. Some people are more active than others.
Always.
We are maybe 10 people who are pretty active.
Okay.
I mean, there's especially one person who writes like 50% of the code these days.
And it's not you?
No, it's not. I spend too much time on internal things, and it's hard to find time to write much code these days.
Okay, so what does that mean for your hopes for the project? I mean, are you envisaging a day when one day there's a JJ Hub, which Microsoft are wishing they bought years ago?
Yes. I think a lot of us in the community are hoping for that day too. And yeah, this actually is something I've been a little surprised about, how open the community is to the kind of workflows we have at Google and supporting our integrations here, because they're not immediately relevant to most of the community yet, but we're hoping that we'll get there eventually, like having this kind of cloud-based, cloud-hosted repositories outside of Google too, and the virtual working copy that we have at Google have something like that outside of Google too. So yeah, I think many in the community are also looking forward to that day.
What do you think you need? I mean, is this a project that just interests you and is the way you want to work, or are you trying to like broadcast to develop a mind share, like come over to the light side?
I'm not sure, but yeah, I think we have. It seems like the community, like we have kind of a pretty shared vision for the project, at least. If I'm not sure I'm answering your question correctly, but
I'm just wondering how much your community is like. How much is this a technical project, and how much is it we need to go for the hearts and minds of developers and say there's a better way than Git?
Yeah, I think I think it's definitely quite a bit of that. I think most of the community is very passionate and like think we have something that's better than Git I mean, not for everyone. I think it's honestly a lot of Git users don't do much more than just Git commit, Git push, Git pull, and that's almost it. They like if you don't your project doesn't have doesn't like care much about keeping a clean history and having small and atomic commits, or if maybe you're just working on your own personal projects, so you don't care much about that either, then there's not much benefits. I mean, maybe undo is nice, but other than that, it's you don't need all the tools for cleaning up history and so on.
Yeah. I'll tell you one place that's come to my mind that I think it would be popular is there are a lot of new programmers, and I might be using that term slightly loosely, like people doing agentic coding, who really need to learn about source control. Right? We've all read the horror stories about the agent made a change and now my repo doesn't work, and how do I undo it? I've got no source control. A simpler model to teach people than Git, where you can just say, type this and you'll save a snapshot, and then you can just ignore it and you'll be able to undo it later.
Mm-hmm. Yes. Yeah, I do think it might be. I honestly have little experience with working with agents myself, but I do think it feels like a model that's perhaps simpler to use with agents, and have the agent produce work in a separate workspace or something, and give you a commit back when it's done.
Yeah. Yeah, I wonder if because I wonder if the reason I found it a little bit hard to get my head around is because of the things I've learned that bend my mind out of shape with Git. I think it might be an easier tool to teach a new user than a seasoned user.
Yeah, there might be some truth in that. Yeah, since like almost everyone already has experience with Git, I don't meet these people much, so it's hard for me to say. But
yeah.
Also we also haven't focused much on documentation for these users because everyone uses Git so far.
Yes. So yeah, I've seen more tutorials for how you come from Git than how you get started completely fresh.
Yes,
it's hard.
Yes.
It's hard to know what you've learned so long ago that it seeps into your bones, I think.
Yeah.
Okay, we're getting too philosophical. Let's pull it back to tech. There's one other thing I wanted to ask you about, like the nuts and bolts, which is what the over-the-wire protocol. Do you just use Git's push and pull mechanism, or do you have something different?
No. Well, yes and no. When using the Git backend, the remote is a Git's remote, like GitHub or GitLab or something like that. So yes, it's just the regular Git protocol, and we even just sub-process to Git push or Git fetch. So yes. Then internally at Google, we have our own protocol that uses gRPC to talk to our server. Yeah, that's completely custom, and it's not defined by JJ, the project itself. It's completely custom to Google.
So is that kind of network stuff the concern of the storage engine rather than JJ itself?
Yes. So there's I haven't mentioned this. We talked about Git, how we actually store stuff in Git before, but I said that we store commits as regular Git commits, but I forgot to say that we also have like a higher level integration with JJ Git commands, and those like bypass the backend storage abstraction, so that they're like talk directly to the Git backend, as I said, run Git push, for example. And so, like similarly, internally, we have these commands called JD Piper, because our backend is called Piper. And they talk directly to our server. And
okay. Then I'm just going to ask you out of pure curiosity, if someone wanted to add another storage engine for their custom needs, what kind of work goes into that? How hard is that? How much work?
It's not very hard. We actually have several different storage backend abstractions, but for just storing commits, all you need is basically read and write file, read and write tree, read and write commits, and that's about it.
Okay.
Like the abstraction is at a pretty low level like that, so you don't need to do anything about diffing or merging, or that's all in the JJ library itself.
Okay. And I would write that in Rust?
Yes. Yeah. I mean, you can obviously FFI to whatever you want, or RPC to somewhere, but yeah.
Okay. That makes it sound like quite a nice separate. I guess Git has that notional separation between the plumbing and the porcelain, as they call it.
Yes, but it's different. Like, they don't have a way of replacing the storage. There's talk about that in the Git project, but I don't think they're anywhere close to actually having it done.
Okay. So I guess you need to sort that architecture out early, or it's a real pain to untie later.
I think so.
Okay.
Yeah.
So I'm going to ask you about the future. Obviously, you're going to finish this call and you're going to go straight to doing bisect just for me. But after that, what are you hoping to put? Is JJ finished? What's next? How much work does it need?
So one of the large current projects, is copy tracking. We don't have support for copies. Like, we have very limited support. We have support that's only with the Git backend, like which is what everyone outside of Google uses. So when you diff two commits, we call into Git's diffing code for detecting copies. But we have a more long-term plan to actually record copies and renames so unlike Git, which detects copies on the fly. So if you do like Git CP, it doesn't actually do anything, as you may know. Like, it just creates a copy of the file.
Because in Git, it's just you hash the file. If it's got the same hash, then it is the same file with a different name, right?
Is that what we're talking about? But like, even if it has changed, then like there's Git. I don't actually remember the flags, but Git diff can detect copies that are just similar. But the point is that Git detects those; it doesn't record them. So if you do Git CP, it doesn't record in a metadata saying that the file was copied.
It's just working on a heuristic of the diff. This hasn't changed much, so it must be the same file originally.
Yes.
Yeah. Okay.
So, but we want to record that information instead. So we have a design doc that took me ages to complete, but like, we have a design now that I believe in, and so we're going to work on that and get support for copies done soon.
Why
hopefully.
Is that good? I'm not instantly seeing why you need to track that.
One reason is that it's expensive to calculate on the fly. like the detecting copies, especially detecting renames, is not that expensive because you only need to find the files that were added and files that were removed in same commit or between the two trees you're comparing. And then like only those are candidates for renames. But like if you have a copy, then you have to look at all the files in the repo to find where it could possibly have come from, if it's just similar to some other file. Git has some different flags for this. Like there's I think it's git diff that has -- find copies harder or something like that to look extra hard for copies, and because it's expensive, so they have these trade-offs depending on what you actually need. But like especially for big repositories like Google, there's obviously no way we can scan the entire repo for all the files. So I think that's the main reason. But yeah, it's also useful to be able to explicitly say that a file has been copied from a particular place. Like I think especially in large repos, it's not obvious. Like if you just detect it, it may detect the wrong file that just happened to be similar, even though it's not where you actually copied it from, and it may be a bit illogical. So I think there are cases like that too.
Especially if you've got, I mean, Google must have, if it's got a mono repo, it must have vast amounts of Java files that look roughly the same, even though they're not copies, right?
Yes. So just detecting it in all those cases would be, confusing, I think.
Okay. I am reluctant to ask you any Google-specific questions for fear the lawyers circle around us. So let me try and ask this in a generic way. You have used JJ on a truly vast repo. How does it perform, and which bits were hard, and did you have to optimize anything when you realized?
It performs pretty well. There are basically two. We run it in two different environments. One is the CLI, where like on the local user's local machine, and we have a daemon process that takes care of caching and stuff, like making. When you create a commit, for example, we just write it to the daemon, and then the daemon flushes it in the background, so that reduces latency locally. And the other environment is the server, which is used for our cloud-based IDE, and that doesn't have as much caching, so things are slower in that environment. It's still comparable or slightly faster to our existing Mercurial-based solution. But yeah, locally it's pretty fast. Like even especially thanks to the caching on the daemon. And we also do many algorithms are like to do things concurrently. So like when we need to read files, we read them concurrently from the backend, for example.
Ooh, okay. That I was going to end there, but you've just opened a can of worms. You're doing concurrent file reading in Rust. Are you using something like Tokyo, some kind of async?
Yes.
Thread pool forking. How's that work?
Yeah, we use async Rust. Yes.
Okay.
Because it's the slowness is almost all I/O. It's not that much processing usually.
Believe that.
So just async even with a single thread is sufficient to make it fast. We still have a bunch of things that are too serial, like, but yeah, it's possible. At least we generally we can do a lot of things concurrently, but like when you walk a tree or two trees to come to diff them, for example, we can. You're limited to the depth of the tree because you can only walk one level of a tree at a time to find what's different at the next level. But like at a single depth, you can do all those read subtrees concurrently, and the files within the trees too.
Yeah, and I see it's like that JavaScript thing as well, isn't it? Like if you just pushed reading the file to an event loop so that you didn't have to block what you're coding while you wait for the file to come back, you can get work done, at least conceptually. You can get work done while the OS worries about pulling the file in.
Mm-hmm. Yeah.
So this is why even single-threaded asynchronous code works better. Yeah.
Yes.
Okay. That was simpler than I expected.
Yeah.
Okay. I have to ask you: is there anything else we've missed out? Anything we should dive into? Any more Easter eggs like that before we go?
You asked about the future. I mentioned the short-term copy tracking. I think long-term I mentioned a little bit before about how we're hoping that will be like a JG Hub or something like that with native cloud-based storage of repos and VFS. And we also want to add better support for large files. So Git has these LFS extension. Git NX, I think, is maybe a different version of it or something. But yeah, we want to be able to support large files better natively and not need so the user doesn't like see a difference between large files and regular files. So that's I think that can largely be solved by these cloud-based forges, like and including the one at Google. Large files is mostly a problem in Git, because it at least before partial clone, Git these days has partial clone support, which doesn't download all the file content, but even with partial clone, it reads files unnecessarily, like when rebasing and other things. So I think anyway, where I was going with this is I think we should be able to support game studios and similar companies that are currently kind of stuck on Perforce because they have large file content. So I would really like to be able to help game studios get a better VCS.
Yes, that would be a huge market. And I could see how rebasing is going to work better with JJ because you don't need to check everything out to a working copy and do sometimes to do very little actual work before you check out a different.
Yes.
How is that going to work, though? Do you have a plan for it?
Well, yeah,
I'm putting you on the spot.
No, we do have a plan. I think much of it will be helped by just having a native cloud-based forge, or so. If you just never download these files and you read them from your backend on demand, and that, as you said, that demand is much smaller than in Git because we don't update the working copy all the time. That helps a bunch, but we're also looking into CDC, content-defined chunking, which should help reduce the amount of content to transfer when you update binary files. Like it splits binary files up into smaller pieces and transfers only like the parts that have changed.
Yes. Now, I don't know the content-defined chunking algorithm well enough that I'm going to open that can of worms, but I do know enough that it's sensibly splitting files, not just at file size boundaries.
Yes. I assume it still depends a lot on the actual file. Like if it's an archive, it's essentially random, and there are no boundaries that match. In that case, it doesn't help. But hopefully, there are files that are more structured.
Yes. If we've got a huge file and I add 1 byte at the start, does that make it look like an entirely new file because all the offsets have changed? That's the algorithm, right?
Yes,
being
exactly.
smart
Yeah.
about that. Yeah.
Yes, exactly.
Okay, I think that that leaves us with an algorithm to go and look up on Wikipedia.
Yeah.
And I need to leave you to go and I feel guilty about saying this. I need you to leave you to go and write JJ bisect for me. While I either go off and beat you to writing JJ hub, or at least get a really nice Vim plugin for JJ going, because that's what I'll need.
Yeah, nice. Yeah.
Awesome.
Sounds good.
Martin, thank you very much for taking me through it.
Yeah, thank you. Thanks.
Thank you, Martin. You'll find a link to Jujutsu in the show notes, and I'd really recommend giving it a trial. It's interesting to use. I'll say, I think the hard part of learning it is with Git, you're used to making your changes and then adding them to a commit. With JJ, it's kind of backwards. You start the commit, add changes to it, and you're only really finished with that commit when you start the next one. And it's a small change of workflow, but it's a big change of ingrained habits and muscle memory. And the payoff doesn't really come until you try and do your first merge or your first rebase. So if you give JJ a try, and I think you should, make sure you get past that initial weirdness and get to the good stuff before you really make a decision, because that's what you want to evaluate. Before you head off to the terminal and install it and give it a try, I have a quick request for the GUI. Please take a moment to like or rate this episode, maybe share it with a friend, and make sure you're subscribed, because we'll be back soon with another guest. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Martin von Zweigbergk. Thanks for listening.